This video is on the objective compute the value of the test statistic or the z-value or z-score for a hypothesis test for a proportion, a population proportion. And this is number 2. Hopefully you've seen the first video related to this objective. So this one I'm going to go through a little more quickly. Again, I'm assuming you've seen the first one. This is a pretty similar kind of problem. So let's take a look. All right. So again, if you're unfamiliar with the topic, you want to see more about it, please click on More Instruction and look at their videos, their notes, their examples. Hopefully those help you out. Okay, so here a researcher is investigating a government claim that the unemployment rate, probably for the whole country, the entire population, is less than 5%. To test this claim, a random sample of 1,500 people is taken, and it is determined that 92 people, 92 of those, are unemployed. Alright, so in this particular question, being unemployed is our success, as weird as that might sound. Now, they have set up the hypotheses for us. Right. Notice the claim here is that the unemployment rate, the proportion of the nation that's unemployed, P, is less than 5%, and that does not involve equality, so you notice how it's in the alternative hypothesis. P is less than 5%. And then, P is greater than or equal to, but what we're going to assume is the equal part, is the null hypothesis. So P equals 5%, and this is going to be assumed. All right, we are going to assume the null hypothesis. We're going to assume that the unemployment rate for the nation is 5%. All right. So now let's go to our sample. I'm going to just pull up a piece of paper on this page here. Hopefully you can see this. So let's take a look at our sample. All they ask us for is the test statistic. Now the size of the sample is 1,500. Right, that's the N. If you remember from the first video on this objective, remember lowercase x represented the number of successes. And here we're talking about, unemployed. Right? Being unemployed is a success in this problem. And of these 1,500 people, 92 of them were unemployed. So then the sample proportion, right, the sample proportion, what proportion of now P, it could be P hat, like this, or P prime with a little apostrophe, same thing, is just, 92 out of 1,500. All right. So let me go to the paper, make it a little bigger. Now 92 out of 1,500. Punch that in. So it's approximately 0.0613. Right, a little more than 6% of this sample was unemployed persons. All right. Now, if you recall, the sample size is pretty large here. By that central limit theorem for proportions, the distribution of p hats would be approximately a normal distribution with a mean of p and a standard deviation of the square root of p times 1 minus p divided by n. Now P is assumed from the null hypothesis, right? This is from the null, I'm not using P hat here. This P we have assumed from the null hypothesis that this is 5%. So we have a normal distribution with a mean of 5%, 0.05, and a standard deviation of 0.05, the square root of 0.05 times 0.95 divided by 1500. Right. And all they're asking us to do is calculate the test statistic. Remember, the test statistic, if this is a normal distribution and not a student's t, is a z-score. It's a z-score, and where we're taking our sample proportion and determining its z-score in this normal distribution, the distribution for sample proportions. So I take our p hat, we take our sample proportion, take away p, right, the mean of the normal distribution, and divide that by the standard deviation of this normal distribution, which is the square root of p times 1 minus p over n. All right, so I'm going to enter this, and they're asking us to round this to 2 decimal places. All right, so on the calculator, now I already have, that's the mean, so I'm just going to take, in parentheses, I'm just going to take that as my, my previous answer. All right, my previous answer, there's my p hat. Subtract 0.05. All right, that was the assumed proportion from the null hypothesis. Make sure that's all in parentheses, and then divide by, and then the square root of, and then again make sure all of this is in the square root. P 0.05 times 1 minus p 0.95, then divided by the sample size 1500, all inside that square root, and that's all in the denominator. Alright, so we're getting a z-score, if I round to 2 decimal places, of about 2.01. That's all they're asking for. Alright, so our p hat, our sample proportion, is a little more than 2 standard deviations above 0.05, above the mean, right, in this distribution of p hats for samples of size 1500. Okay, and that's all they're asking for. And then after that, we'd find, critical values or p-values, and then make decisions about the null hypothesis. Do we reject it or not reject it? We're going to do all that in later videos. For right now, all they want is that test statistic, to 2 decimal places, 2.01. Submit it, check it out. Great, wonderful, keep it up and all that. And then look at the calculations they made, the exact same calculations I showed you. Alright, so hopefully watching my videos or looking at the more instruction provided by Newton Alta, hopefully doing that stuff will help you when you're working on the questions related to this objective on your own. And thanks for watching.